Welcome to SOC Minute Weekly, where we break down the cybersecurity stories that mattered most this week and what they mean for defenders. This week, we're looking at wallet seed generation failures tied to major thefts, critical vulnerabilities across hosting, analytics, laboratory, and infrastructure software, and phishing campaigns that keep finding new ways around trusted controls. We'll also examine large-scale package supply chain attacks and a growing set of AI security incidents. There are 16 stories to unpack, so let's start with the wallet failure behind a remarkably fast theft. About 1,082 Bitcoin were drained from 1,196 addresses in just 41 minutes. The theft was linked to predictable seed generation in Coldcard firmware, not one owner losing a recovery phrase in a single bad moment. And that changes the trust boundary completely. A hardware wallet may protect keys after creation, but if its seed was predictable from the beginning, the attacker may not need the device, malware, or a fraudulent transaction approval. The reported issue traces back to a 2021 firmware error involving a software-based pseudo-random number generator. The first task is to identify affected devices, determine when their seeds were created, and map the addresses involved. Then, watch for rapid, unapproved movement. 41 minutes leaves almost no response window, and updating the firmware now would not make an already generated weak seed safe. Right. A device that once ran vulnerable code is not automatically compromised, but a seed created under that condition may need to be treated as permanently exposed. CVE 2026-58048 created a different boundary failure. An authenticated cPanel hosting customer could execute SQL as the database root and potentially reach data belonging to other tenants. Authenticated doesn't mean low impact here. The attacker starts with a legitimate hosting account, but database root access sits far beyond the permissions that customer should have. So patch the affected cPanel instances. Then review database activity for root-level queries tied to ordinary hosting users, especially reads or changes involving another customer's databases. The investigation depends on whether those logs retained enough tenant and user context. A root query alone isn't proof of exploitation. A root query originating from a customer boundary is a much stronger lead. A high-severity flaw in Thermo Fisher Applied Biosystems genetic analyzers could allow an attacker to modify DNA data output files. Here, the target is not simply a system, it is the integrity of the result. Altered output could lead to inaccurate test results, although the reporting does not establish specific exploitation cases. If a laboratory trusts that file as the analyzer's result, changing it attacks the basis for downstream decisions. Labs should identify affected analyzers, map where their output is stored, and determine which users and processes can modify it. Legitimate exports and reprocessing mean that not every file change is malicious. Older end-of-life units make this harder because updates are not available for every model. File history, authentication events, and reconciliation with the expected laboratory workflow may be the only practical controls left. Next is a patch roundup covering Veeam, Terraform MCP server, and Django, including a maximum severity CVSS 10.0 issue. The important point is that these are separate products with separate vulnerabilities and owners. Exactly. Teams should not treat them as one shared exploitation path or assume every issue has the same cross-tenant impact. Each deployment needs its own affected version check, exposure review, and vendor-specific remediation. That starts with finding the Veeam Service Provider Console, Terraform MCP deployments, and Django applications in the environment. Then assigning each one to the team that can verify its actual configuration and patch level. If there is concern about prior access, use the telemetry appropriate to each product. Authentication and tenant activity for managed consoles, agent and tool call records for MCP services, and web or application logs for Django. A generic patched status is not enough.
Metabase had a critical SQL injection 0-day that was actively exploited for data theft, with Framework and Tally disclosing related breaches. An analytics platform can be much more sensitive than its dashboard interface suggests.
Metabase often holds database connections, saved queries, and broad access to business information. The investigation must ask not only whether the application was reached, but what its connected data sources exposed.
First, locate every instance, including departmental deployments outside the central inventory. Then, correlate Metabase access and query activity with database side logs and external connections around the suspected window.
Analytics traffic is noisy, so a strange query needs context. Unexpected external access, unusual data movement, or queries outside a user's normal role will be more useful than searching for one universal indicator.
A Microsoft 365 adversary-in-the-middle phishing campaign is targeting payroll and finance conversations. A user can complete MFA and still give the attacker an authenticated session token.
The attackers also use residential proxies to blend in, but a consumer IP is not automatically malicious. The stronger signal is what follows: mailbox rules, new delegation, unusual access to finance threads, or payment-related activity.
Prioritize accounts involved in payroll and payments, then correlate sign-ins with phishing events and mailbox changes. But what happens when the successful MFA event is itself part of the compromise? It can't be the point where the investigation stops.
And avoid treating residential proxy as a verdict. Behavior after authentication may reveal the compromise more clearly than the source IP, especially if the attacker quietly reads payment conversations instead of acting immediately.
DoubleCup is a loader as a service using ClickFix and hiding malware inside PNG images stored in the browser cache. It can deliver Count Loader and Device Manager, a new Windows remote access Trojan.
The technique reaches Windows and Mac OS, while Device Manager itself is identified as a Windows rat. That distinction matters when teams decide which endpoints and behaviors to hunt.
A cached image may be the clue, but browser caches are noisy. Correlate suspicious image access with browser child processes, command execution during the ClickFix sequence, and subsequent loader or rat activity.
Behavior has to carry the case. Treating every PNG as suspicious would create noise, while ignoring cache artifacts entirely could hide the point where the payload entered the execution chain.
That connects directly to the ClickFix story. Once again, a legitimate user action is being redirected toward an attacker's goal. Greatness Phishing as a Service now initiates an OAuth device authorization flow and convinces the victim to approve its code.
So the flow is not technically breaking MFA, it is phishing the authorization. The user may complete a legitimate security step, but for a session the attacker controls, resulting in a usable token.
Inventory applications that legitimately use device authorization. Then look for unexpected device code requests, token issuance, and follow-on access that does not match the user's normal behavior.
A device grant by itself may be normal. The challenge is whether identity logs preserve enough context to connect who initiated the flow, who approved it, and what the resulting token did afterward.
ChainDrop reportedly spread through more than 1,300 NPM packages, with around 2 billion monthly downloads between them. That figure describes potential reach, not 2 billion confirmed infections.
The useful question is whether a known affected version entered your environment. Review dependency inventories, lock files, package install records, build logs, and artifact history instead of hunting for only one library name.
Then, separate development exposure from production impact. A workstation fetching a package is not the same as a release build incorporating it, but both may expose credentials or provide a path for propagation.
If the dependency reached a build, trace the resulting artifacts and look for unexpected activity from runners or deployed applications. The inventory to artifact chain turns a huge headline into an investigation scoped to your environment.
Attackers used SQL injection against Oracle and compiled the Khunt toolkit as Java source inside stored procedures, avoiding the normal pattern of dropping an executable to disk.
That shifts the evidence toward the database. Oracle's Java stored procedure capability becomes the execution path, so host-focused detection may miss activity buried in procedure creation and execution records.
Teams should establish whether Java compilation is normal in that Oracle estate, identify who initiated it, and review stored procedures that begin driving unexpected commands.
Tie those records back to injection attempts and application access. The reporting does not provide a complete intrusion chain, but it clearly shows why database audit logs cannot be treated as secondary telemetry.
This connects back to ChainDrop, but the scale isn't the only thing that caught me. Nearly 800 typo-squatted packages used AI-generated names to distribute a rat and Infostealer across Windows, macOS, and Linux.
I had the same reaction. Those names are meant to disappear into normal dependency searches, but the package count still shows breadth rather than confirmed impact. We need to separate exposure from execution.
So, where would you start? The developer laptop or the build pipeline? I'd check both. If a package reached CI, investigate which credentials, secrets, and artifacts were available. Then, look for unusual child processes and outbound connections.
And don't narrow the hunt to Windows. A Linux build agent or Mac developer laptop can be equally relevant. Package names identify potential exposure. Endpoint and network behavior tell us whether it became something worse.
I initially wondered whether this was a second theft. It isn't presented that way. Another report places the losses tied to the same Coldcard random number generation flaw at about $88.6 million, instead of the earlier $70 million estimate.
The reporting doesn't establish one definitive reason, but scope, valuation timing, or newly attributed addresses could change the total. We shouldn't invent an explanation or present it as a separate compromise. The defensive conclusion remains the same. Identify seeds created under the vulnerable condition, treat them as potentially exposed, and move assets to keys generated with trustworthy entropy.
Unlimited Technology Systems disclosed an October 2025 breach affecting more than 3.8 million people. Healthcare information does not become harmless with age, but the public account leaves important details unresolved.
The disclosure establishes the scale, not a confirmed intrusion path, complete data set, or proof that every connected customer environment was accessed.
Organizations connected to the platform should map applications, repositories, service accounts, and integrations. Then, preserve authentication, API, and access activity around the incident period.
A vendor breach justifies review, not an assumption of compromise. Baseline changes, unusual destinations, odd timing, and identities operating outside their normal role will be more useful than volume alone.
Meta confirmed that one of its AI models reached a real company during a misconfigured cybersecurity test. The incident was not a model crossing a correctly enforced boundary. The test scope and controls were configured incorrectly.
That distinction matters, but it does not remove the impact. If an autonomous system can act against an external target when scope is wrong, the test environment needs the same authorization and containment discipline as a human-led assessment.
That means constrained credentials, network controls, explicit target allow lists, human stop mechanisms, and logs showing what the agent attempted, where it connected, and whether it accessed anything.
Autonomous cannot mean unobserved. Teams need to distinguish approved test activity from unplanned behavior before an external party has to tell them their own security exercise crossed the line.
That AI testing story connects directly to Paperclip. At first, I heard agent import and thought routine platform administration, but two critical flaws reportedly allow malicious imports to trigger remote host command execution.
That's what makes it easy to underestimate. There's also a separate API issue involving sensitive data exposure. So we're looking at two paths: command execution through agent imports and possible disclosure through API endpoints.
How would we tell a normal import from the beginning of an intrusion? Identify every Paperclip instance, review who imported which agents, and correlate those events with host commands. For the API path, inspect unusual endpoints and request patterns.
The risk is development noise hiding the signal. If we can't connect an approved AI action to an identity and expected execution chain, routine experimentation and host compromise may look almost identical.
Talos reviewed prompt logs from cloud AI applications used by threat actors. The important finding is not that AI suddenly creates new attackers, but that existing actors are integrating it into work they already perform.
There is no universal malicious prompt signature. Legitimate users also ask unusual questions and paste imperfect code. So prompt content without identity, application, and follow-on activity can be misleading.
Defenders need to know which cloud AI services are sanctioned, what audit data they retain, and whether generated phishing or malware-related material can be connected to a user in an incident timeline.
Network logs may show access to an AI domain without revealing what was submitted or returned. The practical goal is to understand expected AI activity and preserve enough application-side context to reconstruct when it becomes part of an attack chain.
The common thread this week is context. A login, package installation, database query, or AI action can look ordinary until the surrounding identity, tenant, and follow-on activity tell a different story.
Choose one high-value system and test whether you can connect the user or tenant, the action, and the resulting access or data movement. If that chain breaks, find out which record is missing.
And remember that a patch fixes exposure going forward. It does not explain whether a weak wallet seed, stolen token, malicious package, or unsafe agent action already caused damage.
That's it for this edition of SOC Minute Weekly. Thanks for listening. Stay safe, stay informed, stay secure, and we'll see you next week.